Working Group 145 is concerned with chemical speciation modelling, which is widely used in analysing and interpreting the interactions of seawater with the biota, sediments, and the atmosphere. Almost all published modelling results use individual models that lack full documentation of the model parameters used and their sources. Our goal is to address this problem with freely available software as set out in our vision. The introduction of full documentation, validation, and uncertainty estimates is a major step forward in this field. The aim of this presentation is to provide an update on the working group's progress over the past year. First, Simon Clegg will present an overview of the development of the chemical speciation model for next year's software release. Next slide.
Model development. We have completed the following models. A, one of major ion artificial seawater, including acid-base equilibria. B, one of tris buffer in artificial seawater, enabling us to model the properties of the buffers used to define the marine pH scale. And C, solutions containing the ions of standard seawater, including carbonate and borate equilibria. 2. What can these models do? They can calculate equilibrium speciation and activities in solutions containing the above ions, but with arbitrary, not necessarily seawater, composition. 3. What is different about these models? We can estimate both a total uncertainty for any model output and also individual contributions of every pizza parameter and equilibrium constant. This is really invaluable for future model development. Last, the example shows the percent variance contributions to calculated total pH of a salinity 35 buffer. The greatest contribution, just visible at the top, is that of the thermodynamic equilibrium constant for bisulfate and dissociation. Next slide.
The goals and expertise of this working group have attracted the interest of several other international initiatives. These are shown in the table, together with the names of working group members engaged in each project. 3 of these projects involve the definition and measurement of seawater pH, which is the subject of the next slide.
For pH, we have first quantified the neglected terms in the definition of the total pH scale and the difference, therefore, between total pH and minus log 10 of hydrogen ion plus bisulfate concentration. Second, we've evaluated how best to extend the total pH scale to low salinities, assisting in doing this the EU Safeties project. We have also presented in our manuscripts detailed recommendations for further work to improve and extend the models. And the models have also been very helpful in designing our experimental program, which will begin at NIST in December of this year. The second example on this slide shows, first, the defined total pH of a salinity 35 artificial seawater for a range of buffer molalities on the x-axis. This is the uppermost dashed line. The solid line below it shows, for the first time, the true hydrogen ion concentration in the buffer. The difference between the two is due to assumptions in the definition of the scale. Next slide.
DESAMP Working Group 45. The group of experts on the scientific aspects of marine pollution, which is sponsored by multiple UN agencies, has very recently established this wide-ranging working group, focusing on oceanic contaminants in a changing climate. We look forward to contributing our expertise to the work of this group. Next slide. We are now in an intensive period of publication, where a major goal is to publish a complete peer-reviewed documentation of the 2022 software release in the open scientific literature. Our other publication plans are papers on the program of thermodynamic measurements carried out by our collaborators in National Metrology Institutes, and completion of a paper setting out a proposed best practice in chemical speciation modeling. Next slide. The next 12 months will see the completion of our SCORE terms of reference with the release of the freely available software for chemical speciation modeling. We request that we retain our status as a SCORE working group until autumn next year, so the software can be released as the product of a SCORE activity. In addition to highlighting a SCORE contribution to marine science, we believe that SCORE's prestige will foster acceptance and use by the marine science community. Next slide. Looking to the future, next year's software release represents a valuable first step, but is by no means the final end product. While documenting and verifying the model, we've identified and prioritized the work needed for further improvements. There's significant interest from working group members in continuing collaboration and seeking new funding beyond the 2022 software release. We are aware that association with an international organization would provide visibility for this work and have begun informal discussions with the Joint Committee on Seawater. Next slide.
Further reading. This presentation has provided just a brief overview of our work. More details can be found in a digital poster which is available on our website, MARCHEMSPEC.org. This also has abstracts of our 2 submitted manuscripts that describe the modelling so far that we submitted recently. Thank you for your attention.